All right, so this is going to be kind of our discussion on percent yield. And so percent yield is looking at how efficient a reaction is. When you calculate percent yield, you are going to take, forgot my L, your actual yield divided by what we call your theoretical yield. And then you're going to take the whole thing times 100%. So when you calculate these, you will always be giving your answer in the form of a percent. Apologize for my bad handwriting. I'm working on this iPad. It's new to me. So your actual yield, oh my goodness, is going to be what you're finding in lab. And so we would say things like, this many grams were produced in your reaction, or in your lab you found this many grams. Your theoretical yield is what we've been practicing these last couple of days. And so this is what you're going to find using your stoichiometry. And so you're going to take your grams and turn them into moles. You're going to use your mole to mole ratio, and then you're going to figure out, theoretically, if everything went perfectly, how much you could form using that reaction. So you guys have this sheet on Schoology. I'm just going to do the first couple with you to kind of walk you through some examples. And so for this first one, it says a reaction with a calculated yield of 9.23. And so this would be your, change colors here, this 9.23 would be your theoretical yield. And then it says it produced 7.89 grams of product. So this is what we actually got in lab. So this would be your actual yield. And so in this case, the only step that you have, because I gave you both your theoretical yield and your actual yield, is going to be to calculate your percent yield. And so percent yield is that actual value, so 7.89 divided by your theoretical, so 9.23, and then times 100%. So just give me a second. I'm going to plug this into my calculator. And so when I take 7.89 divided by 9.23 times 100, ends up giving me a percent yield of 85.482. And when you do these, you always want to consider significant figures. So 9.23 has 1, 2, 3 significant figures, no zeros involved, as does 7.89. And so we're going to round our answer to 3 sig figs. So if we count from the left to the right, 1, 2, 3, you're going to round your answer to the nearest tenth. And so you would say your answer here is 85.5% yield, which just means that you made 85.5% of what you expected to make. If you look at number 2 now, I gave you a balanced reaction. So this one I balanced for you. Number 3, you're going to have to do the balancing yourself. In order to find your percent yield, you first need to find that theoretical yield. And so that's where your stoichiometry is going to come in. And so our first steps here is you had 9.87 grams of ammonia. And the ammonia is the NH3. And you cannot compare grams to grams, so your first step is always to take your grams and turn them into moles. So if we think about units, we want grams to cancel, so we're going to put grams of ammonia on the bottom. And we're trying to turn that into moles of ammonia. When you go grams to moles, moles to grams, the mole always gets the 1. And then you're going to use your periodic table to find your grams of ammonia. And when you do that, you have 1 nitrogen atom, you have 3 hydrogen atoms, so you're just going to add up those masses from your periodic table. So 1 nitrogen and 3 hydrogens ends up giving us a mass of 17.04. And then I strongly encourage you guys to cross off your units as you go. So we've gotten rid of the grams of ammonia, and now we're in moles. And so our next step now is to use our mole to mole ratio. And again, consider your units. You want moles of ammonia to cancel, so that needs to be diagonal. So we're going to put moles of ammonia on the bottom. And we're trying to find moles of urea, so we're going to put that on the top. And I am CN2OH4. And when you do that mole to mole ratio, you're always going to look at your balanced chemical reaction. And so there is a 2 coefficient in front of ammonia, so that's what you're going to put in for your number for ammonia. There is no coefficient in front of urea, so you're going to put in a 1 for that ratio. And then again, cancel your units as you go. So now you've crossed off your moles of ammonia and we've made it into moles of urea. Ultimately, if you're going to use percent yield, you need to have grams of urea. And so our last step then is to take those moles and to turn them back into grams. So you want moles of urea to cancel, so that's going to have to go on the bottom. Oops. CN2OH4. And grams of urea will go on the top, so CN2OH4. And again, you're going to use that periodic table and you're going to add up the mass of everything that is in that urea molecule. So 1 carbon, 2 nitrogens, 1 oxygen, 4 hydrogens. Just give me a second to do that. Gets us a mass of 60.07 grams. Take care of your units as you go. So we're going to cross off moles of urea, and then we can do our math. Again, grams to moles, moles to grams. The mole should always have a 1. And so then you're just going to calculate. You're going to divide by everything that shows up on the bottom. You're going to multiply by everything that shows up on the top. So we're going to take 9.87, we're going to divide by 17.04, we're going to divide by 2, we're going to multiply by 60.07. And that ends up giving us a theoretical yield of 17.397. We're going to sig fig this, so we started with 3 sig figs, we should end with 3 sig figs, so we are going to round to the nearest tenth. So our theoretical yield would be 17.4 grams of urea. And then part B for this reaction is asking you now what's the percent yield if your actual yield is only 13.74. So So we're going to go percent yield is your actual. And so that would be your 13.74 grams divided by your theoretical, so 17.4, all times 100%. So if we plug that into our calculator, we've got 13.74 divided by 17.4 times 100% gives us 78.96. And because we had only 3 sig figs in your 17.4, you only want 3 sig figs here. So again, we're going to round to the nearest tenth. And your 6 is going to cause your 9 to go up, which is going to cause your 8 to go up. And we're going to end up rounding to 79.0% yield. So there's 2 more problems on here that we would like you to try on your own. There's a key posted to Schoology. And then there is some practice for you to submit.